Our next lesson is on solving equations with variables on both sides. So typically, we've been able to keep a variable on either the left side or on the right side. So it's a lot easier to say this number equals x or x equals this number, because we don't have x's on both sides, so we can't say something like x equals x plus 2, right? We'd have to change something. So this lesson deals with those situations where you have an x on the left side and an x on the other side, and we want to get it down to, again, x equals a number or a number equals x. So that's our goal. Your book is going to be set up like this. You're going to have some practice problems to do on the left side, and you're going to have the 4-window example like you did for the last lesson, where the flaps are going to open with example problems and the solutions to those example problems using color. Okay, my variables are going to be in blue and my steps are going to be in red. So those are the two colors I'm going to be using, blue and red. And let's keep the foldable out of the book, and we're going to work with the first example here. What is the solution of 5x plus 2 equals 2x plus 4? So I'm going to open that up, and we're going to start working on the problem here on the left side. So I notice that I have x on two different sides, and my goal when I finish is to get this all the way down to, right, x equals and then some number, okay? Or it could be some number equals x. It all depends on which side my x ends up being on. So let's take a look at how we can go through and get x to be on one side. So right here I notice that I have 5x plus 2 over here, and I don't have any other x's to combine on the left side. On the right side I've got 2x plus 4, and there's nothing else to combine on the right side, so I don't have any like terms. So now I want to get the x to be on the same side, and I have two options. I can either move this 5x over here so that both of them are on the right, or I can move this 2x over here so that both of them are on the left. So you kind of have to be strategic in your thinking about what you want to work with. Let me explain my thought process when I see a problem like this. If I see that I have more x's over here than I have over here, right, I have 5 x's here and 2 x's here, I'm going to move this one over here. Okay, because what I'm doing here is if I have 2x and I want to move things to the other side, I do that by either adding or subtracting. So I'm going to subtract 2x from both sides. And when I do that, I'm going to write it right on top of each other. So my first step here is to subtract 2x. And after that step, look, I don't have any more x's on this side. All I have on the right side is a 4. And on the left side, if I have 5 x's and I take away 2 x's, then I have 3 x's remaining. And again, my variable is going to be in blue. And don't forget that plus 2. And now it's back down to that one or multi-step, two-step equation where x is on the same side. So I still want to move everything away from the x, right? Because my goal is to get it down to x equals some number. So my next step is to get rid of this 2. So I'm going to subtract 2 from both sides. Subtract 2, subtract 2. 2 minus 2 is 0. So on the left side, all I'm left with is a 3x and 4 minus 2 is 2. So I've got 3x equals 2. So I don't have it down to just x yet, right? I've got one more step. I have to get rid of the 3. So right now x is being multiplied by 3. The opposite of that is dividing. So I want to divide both sides by 3. Divide by 3, divide by 3, those 3's cancel, and my final solution is going to be x equals 2/3. Because that's not a nice decimal, right? That would be 0.66666. We're going to leave it as just x equals 2/3. Okay, and that's it. We didn't need that because x ended up being on the left side. So that's it for example 1. For example 2, we're going to solve for x. We've got 10x plus 12 equals 2 times the quantity 5x plus 6. So let's dive into that one. Again, I write my variable in blue. It's a different color. And let's see how to attack this problem. A couple different things I could do. I'm going to start with just the easiest method, which would be to get rid of these grouping symbols here. I can't look at combining like terms unless I know what my terms look like by themselves. Right now I have 2 terms here, but they're being multiplied by 2. So I have to get rid of that. So I'm going to distribute the 2 in. So distribute the 2 in. And that leaves me with 10x plus 12 is equal to, and 2 times 5x is 10x, and then 2 times 6 plus 12. Now, that looks kind of odd, or it should. I have 10x plus 12, and that equals 10x plus 12. So I have essentially something that's equal to itself. So let's see what we can do getting rid of those variables. Let's move the variables to the same side. Now, when we did this one, I talked about kind of moving the smaller variable over. So I moved the 2x over here because there were less of them. On this one, they both have 10x's, so it doesn't really matter which one I move. So my step is going to be to subtract 10x from both sides. So I subtract 10x, subtract 10x. Let's see what I have there. Now 10x minus 10x, that would be 0. If I have 10 x's, I take away 10 x's, then I don't have any x's left. So on the left side, there's just 12. And on the right side, the same thing happens. Those cancel out, and I'm left with 12. So now I have 12 equals 12. And you got to think about it. So when we solve equations, we want to try and find a balance. And the reason we solve for variable is because whatever that variable equals makes that equation balanced. It makes it true. But look what happened here. We got rid of the variables completely. They're gone. I just have 12 equals 12. And 12 equals 12 is already balanced, right? 12 equals 12, just like Mary equals Mary, or John equals John, right? If the left side equals the right side, it doesn't matter what the variable is. So when you get rid of the variable and you have a true statement, okay, 12 equals 12 is like a true statement, that means your solution is going to be infinite. So we say infinite solutions. And that's how you answer it. You don't say true statement, you say there are infinite solutions. Because it doesn't matter what x is. Let's say x is 2. 10 times 2 is 20, plus 12 is 32. 5 times 2 is 10, plus 6 is 16, and 2 times 16 is 32. Right, so it doesn't matter what value x is, the equation's always balanced. It's always true. So that's the solution for number 2. And now let's look at number 3. So we're solving for m. We've got 9m minus 4 equals negative 3m plus 5 plus 12m. Kind of a lot going on in this one. So let's dive in. I'm going to open it up and I'm going to rewrite it on the inside, but I'm going to use blue for m and pencil for the rest. Now, as we start to solve it, let's take a look at the equation. Do I have grouping symbols like I did on number 2 that I have to get rid of? No, right? No parentheses, no brackets, no grouping symbols. The next thing you want to look for is like terms that you can combine. So let's look. On the left side, I've got a 9m and a negative 4. This has m's, this is just a 4, nothing I can do. On the right side, I've got negative 3m, positive 5, and a positive 12m. In this case, I have like terms on this side, right? Both of these terms have m as their variable. So I can combine them together. So my first step here is to combine my like terms. So on the left side, nothing changes. I've still got 9m minus 4, and that equals negative 3m, positive 12m. When I combine those together, I get positive 9m, and then it's plus 5. Now this should look kind of funny too. Similar to the second one we did, right? Both of them have the same amount of variables on the same side. When I start thinking about moving variables around, and I'm trying to figure out, should I move the right ones over to the left or the left ones over to the right? In this case, it doesn't matter because both of them have a 9. So if you don't see what's happening yet, let's keep going. My next step is to subtract 9m from both sides. So I subtract 9m and subtract 9m. And make sure you write those variables right on top of each other so it doesn't look like you're taking a 9m away from the 5. Right? We wouldn't want to write it over here. And let's take a look at what happens. So 9m take away 9m would cancel out, and I'd get negative 4. And that equals, these cancel out, positive 5. So negative 4 equals 5. Does that make sense? Is negative 4 ever going to equal positive 5? No, right? It doesn't. So this is what we call a false statement. Because it's not balanced once we get rid of the variables. And in fact, there's no value for m that we could use that would make it balanced, because this is negative 4 and this is 5. Negative 4, 5. If I add 9 anythings to both sides, it's still going to be a difference, because this is negative 4 and this is 5, which is unlike this one, because this was 12 and that was also 12. So when you get it down to a false statement, that means that there are no solutions. And that's it for example 3. Our final example is number 4. So what is the solution of the quantity 5x minus 1 divided by 3 is equal to the quantity x plus 11 divided by 2? This is kind of similar to that other example we had with multi-step equations, where there was a fraction and there were variables in the numerator, and we had to do something with the denominator. We're kind of going to do that here. So let's open it up. I'm going to rewrite it, but I'm going to have my variable be in blue. And when you have a fraction that's equal to a fraction, that should remind you of something called proportion. If I know that this fraction is equal to this fraction, then I know that they're proportional. And products that are proportional mean that I can take the cross product. And if that term doesn't sound familiar, this part might, right? I'm multiplying across. So what happens now is I have 2 times the quantity 5x minus 1. And that should equal 3 times the quantity x plus 11. And those are my cross products. My next step would then be to distribute on both sides. So 2 times 5x is going to give me 10x. And 2 times negative 1 is going to give me negative 2, or just minus 2. And that's going to equal what I distribute on the right side. 3 times x is positive 3x. 3 times positive 11 is positive 33. And now it's similar to our first example, where we have x's on both sides. So we got to figure out which one we want to move. Do I want to move the 10 over here or the 3 over there? And this is where you want to be strategic again. So if I move the 10 over here, and I take 10x's away from 3x's, right, because I'm subtracting 10x, then I'm going to end up with a negative number. And I don't really like working with negative numbers. So I'm going to move the 3x over, because the 3 is smaller than the 10. So my step here is going to be to subtract 3x on both sides. Subtract 3x, subtract 3x. 10x minus 3x means I have 7 x's remaining, and I still have a minus 2, and that equals, those cancel, equals 33. So now I have the x on its own side, but it's not by itself, so I have to start moving things away from it. And I start from the outside working in, so I'm going to add 2, because that's the opposite of subtraction. Add 2 to both sides. I add 2, add 2. I'm left with 7x. The 2's cancel, so it's just 7x equals 33 plus 2 is 35. And now I have 7 x's, but I want to figure out what 1 x is, right? I got to get rid of the 7. So I'm going to divide both sides by 7. Divide by 7, divide by 7. Those cancel, and I'm left with x equals, and 35 divided by 7 is 5. So there's my solution. So that's your foldable for solving equations with variables on both sides. I'm going to have you do some practice problems on the left side and then show your teacher. Once you get those right, you can move on to the practice problems from the textbook. On the left side, you're going to do these 3 practice problems. Pointed out for you, there's 7k plus 2 equals 4k minus 10. Number 2 is 4 times the quantity 2y plus 1 equals 2 times the quantity y minus 13. And that last one, 3 times the quantity 4b minus 2 is equal to negative 6 plus 12b. And once you get those 3 finished, you'll move on to the textbook practice, but have your teacher check your answer.